Fluids, something that we see everywhere and is essential for our survival. 71% of Earth's surface area is covered by oceans, and they contribute to 97% of Earth's water. The flow of rivers and lakes have shaped the Earth's terrain and have contributed to some magnificent landscapes as we know them today. We rely on this water for our survival. The air we breathe is another excellent example of a fluid without which life could not have existed on Earth. The study of fluid flow is important not only from its fundamental principles and concepts, but is extremely critical in several fields of science and technology. The use of fluid flow principles in engineering applications is quintessential. The automotive and aerospace industries rely heavily on the principles of aerodynamics to design faster, cheaper, and energy-efficient means of transportation. Understanding the cloud formation is essential for an early prediction of weather patterns. The learning obtained from fluid dynamics is heavily used to understand and forecast natural disasters such as floods, tornadoes, hurricanes, and tsunamis. A reliable forecast helps prevent severe losses to human life. Most of the electricity in the world is through hydroelectric power station, where a flowing water rotates a turbine to generate electricity. The design of these turbines is primarily done by understanding the concepts of fluid dynamics. From an engineering perspective, a sound understanding of fluid concepts improves the product performance and quality. An engineer can optimize these engineering applications and improve efficiency at a reduced cost. In addition to these, the safety standards are important for nearly all engineering applications. And a good understanding of fluid dynamics provides these engineers with product failure estimates. This makes the product safer and less accident prone for the end user. In nature, matter exists in three different phases: solids, liquids, and gases. In solids, the atoms are tightly packed into a dense structure. As the atoms in solids are arranged in a regular manner, solids retain their shape and volume. The atoms and molecules in a liquid are not regular, and a liquid takes the shape of a container to which it is confined. If a liquid is not confined, it starts to flow. The atomic arrangement in gases are extremely irregular and are loosely packed compared to both solids and liquids. Because of this loose packing, a gas occupies the entire volume of the container. These large distances between gas molecules allows them to be compressed. We usually refer to both liquids and gases as fluids. However, this definition is not entirely sufficient. In our experience, certain solids behave similar to a fluid. What happens when we pick a handful of dry sand? It quickly flows out of our hands and slips through our fingers, even though an individual grain of sand is a solid. In this case, a collection of solids behaves similar to a fluid. What happens when we walk on water? The answer is simple: we drown. However, there is a liquid which is a mixture of cornstarch and water over which we can walk without drowning. Under these conditions, this liquid behaves like a solid, which allows us to do all kinds of things such as walk, run, dance, or even walk upside down. On this liquid, if we were to stand stationary for a long period of time, we would drown. Another day-to-day example of a fluid behaving as a solid is when we apply the toothpaste to our brush. The toothpaste stays put without really changing its shape. its shape eventually changes when we start brushing. If the toothpaste were really a solid, brushing would be a painful process. If this is the case, how do we really define a fluid? And how does it differ from a solid? We will look at some of the properties that define a fluid. In addition to this, we will also address the different types of flows. The same liquid can show vastly different flow characteristics. Certain flows are really smooth and others are more chaotic. Other flows form funnel-like structures. We will look into these flow classifications